Okay, let's have a look at some vector questions. First one says, in the diagram, the points A and B have position vectors A and B respectively. The point P divides AB in the ratio 1 to 2. So that means A to P is one portion and P to B is portion 2. If I were to represent the portions as, let's say, fractions, what would AP be as a fraction? A third. So PB is 2/3 because the total ratio is 3. AP makes up one lot of that total ratio. Yeah? So, find the position vector of P. So what they're asking of us is OP. In order to work out OP, we can go from O to A and then A to P. A to P is how much of AB? A third. So we can go from O to A and we add a third of AB. Now the next question is, how do we work out AB? To work out AB, you can go from, whoa, that was really big, sorry, hold on. You can go from A to O and then O to B. So OA plus a third of minus OA plus OB. You can also write this as OB minus OA, just to keep things, neat. Right, so let's substitute our vectors that we have because we've got OA and we've got OB. So A plus a third of B minus A. We can expand that. A plus a third B minus a third A, which simplifies to 2/3 A plus 1/3 B. There you go. That's how you do that question. Okay, next question. This one is complicated. So I'm letting you know now. Every time I've explained this, not every time, most of the time, my students would just be baffled afterwards. And rightly so, it is confusing. So if you don't get this first time, don't worry about it. It's okay. Watch it over as many times as you want. Try questions. Eventually you'll get there, trust me. But if you feel like you're gonna want to pull your hair out, it kind of comes with this question. So you've been warned. But it's still doable though. I'll try and explain it in the best way I can. So OABC is a parallelogram. P is the point where the diagonals OB and AC intersect. The vectors AC are equal to OA and OC. So let's label this as A. Let's label that as C. Prove that the diagonals bisect each other. Okay. Before I do this, I want to give you a little piece of information which will come in handy later. That piece of information is PA plus QB equals RA plus SB. Sounds like a bunch of gibberish right now, but we'll get there. Don't worry. Let's try the question, and then I'm going to relate that back into the question. Okay. Now, if we have a look at the point P, the point P lies on two different lines. The first line is AC. The second line is OB. Okay? Right. So, let's express each one. Let's express OB. Let's express AC. We'll start with AC first, just because I think it's probably the easiest. What do you think AC will be? Well, to get from A to C, we go along OA in the opposite direction, and then along OC in the standard direction. So we're going from A to O plus OC. So we're doing minus A plus C, which we're going to write as C minus A because it's neater. In order to express OB, what do you think? Well, we can go along along OC, and then along OB. It's a parallelogram, which means this is also A, and that means that is also C. So we can go from O to C, and then we can go from C to B. So we're doing C plus A. Cool. Now we've represented, or we've expressed, both lines which P lies on. Now we want to express the position vector for P taking two different routes. One route is going to go along one line. The other route is going to go along the other line. Now that we've expressed both AC and OB, we want to express OP, but along the two different routes. The first route is going to be, let's say, AC. So we're going to express OP taking the AC route. Okay? So if you have a look at the green lines I've drawn, we're going from O to A and then A to P. O to A plus A to P. A to P lies on A to C, but it's a fraction of the way there. We don't know what that fraction is. So what we write instead is lambda AC. It's a multiple of the way, or it's a fraction of the way. We don't know what that fraction is. We use lambda. Okay, that's one route. The other route is OB. Taking the OB route, let me use yellow. We're gonna go like that. We're gonna go a fraction of the way along OB to get to P. Again, we don't know what that fraction is. So we're gonna use a letter to keep it general. If we've used lambda for one, we're gonna use mu for the other. Mu looks like a U with a long line in front of it. Okay. So OA is A plus lambda AC, which we worked out earlier, C minus A. Then mu OB C plus A. Does that make sense? I hope so. Now, both those vectors represent OP, which means they're both equal to each other. Like this. Now let's expand and simplify. Or expand and group. There's not really any simplifying involved. We can group the A's together. So let's do A bracket. Nope. Let's do bracket 1 minus lambda A plus lambda C equals mu A plus mu C. Okay, so that's just me grouping together. And yeah, grouping together. Grouping the A's, grouping the C's on both sides. Now let's circle back with what we did at the start. What I gave you. PA plus QB equals RA plus SB. In this scenario, P equals R, Q equals S. So these two coefficients of A are the same, and these two coefficients of B are the same. We're going to apply that to this. The coefficients of A are going to be the same. The coefficients of C are going to be the same. 1 minus lambda equals mu. Lambda equals mu. This is a simultaneous equation. So let's substitute. 1 minus lambda equals lambda. So 1 equals 2 lambda. So lambda equals a half. If lambda equals a half, mu equals a half. What does that mean? That means P is the midpoint of both AC and OB, which means they bisect each other, the two diagonals. That was a lot, but I hope it made sense. If it didn't, watch that back as many times as you want. If you feel like you're ready, I want you to try that question for me, please. Cool. Express OP. Right. OA is just A. OM, therefore, will be a half of A, because they've told us in the question, M is the midpoint of OA. Cool. Q divides BC in the ratio 1 to 3. Right. So that means CQ is going to be a 3/4 of A, and QB is going to be 1/4 of A. Cool. Now, we want to express OP, which lies on two different diagonals. It lies on the diagonal AC, and it lies on the diagonal MQ. Okay, let's express MQ. To work out MQ, we can go from M to A, we can go from A to B, and then we can go from B to Q. M to A is a half of A to B is just C, B to Q is a quarter of A. Minus. Yeah, because we're going in the opposite direction. QB is a quarter A, BQ is going to be minus that. When we simplify that, a half A minus a quarter A is just a quarter A plus C. Cool. That is MQ done. Now let's express AC. We can go from A to O and then O to C. A to O is minus A. O to C is just C. So C minus A. Cool, that's that done. Let's express OP in the two different ways. The first one is along or taking the MQ route. Yeah? So we have to go from O to M and then a fraction of the way lambda MQ. O to M is a half of A plus lambda a quarter A plus C. That's route number one. Route number two is OP taking the route or along AC. To do that, we can go from O to A and then a fraction of the way along AC. O to A is just A plus mu C minus A. Okay, they're both equal to OP, so they're both equal to each other. A half A plus lambda a quarter A plus C equals A plus mu C minus A. Okay, so a half A plus a quarter lambda A plus lambda C equals A plus mu C minus mu A. Let's group, let's factorize if we need to. Or we can just make the coefficients of A equal and the coefficients of C equal. So a half plus a quarter lambda equals 1 minus mu and lambda equals mu. That's our simultaneous equation. When we solve, then 5 over 4 lambda equals a half, which means lambda equals 2 over 5. If lambda equals 2 over 5, mu equals 2 over 5. Cool. So that means OP, we can now just sub that into one of the equations we have for OP. We get 3 over 5A plus 2 over 5C. Cool. Part B. Show that P divides AC in the ratio 2/3. Okay. In order to do that, let's express AP. AP is OP minus OA. Can you see that? AP is OP minus OA. So, 3/5 A plus 2/5 C minus A, which gives you minus, 2 over 5 C minus A. That's what it simplifies to. Now AC is 3 over 5 C minus A. That means, that's PC. So we did AP, we did PC. So AP to PC is going to be 2 over 5 to 3 over 5, 2 to 3. There we go. That is how you do the harder arithmetic questions the harder questions for vectors.